Okay, hi everybody. I would like to show you how to do example number 11, which is in our packet on page 5. So if you don't have your packet out, you want to pause this video and go grab your packet and come back and press play. Okay, we're back. So we are on page 5, like I said, and page 5 is solving for time, okay, finding the t-value. We did problem number 10 after a lot of practice making logarithms in Desmos yesterday, so I just want to show you example 11, and then I'll have another video for example 12. So we have a 3-step process here, and hopefully you have these notes in your packet. You can see that the base raised to the exponent equals the answer, and they're color coded there. And if you have this exact kind of format, which we did over here, you can see we had an answer, a base, and an exponent, and we turned it into a logarithm by putting that base down on the bottom. Remember, base, bottom. And then the answer goes in parentheses. So in this case, it would be the 1.5625 in parentheses. And then lastly is equal to the exponent. So up here it was 12t, and then when we changed it to a logarithm, the exponent was all by itself, so we could solve for t. So here is example 11, and I'm gonna, sorry, I gotta go full screen for a second. Go away, bottom. Okay, well, let's zoom in like that. Let's go down, maybe right click, lock the taskbar. We'll see. Okay, this should be big enough anyways. So we read the problem. It says, if you deposit $5,000 into an account paying 6% annual interest compounded monthly, how long until there is $8,000 in this account? So the words, how long until, that's what tells you you're solving for t. The other thing that tells you you're solving for t is that when you make your variables, which I'm going to do f, p, r, n, t, when you fill out those variables, you're going to find you have most of them. So the only one you're not going to have is t, and I'll show you that in a second. So you're going to deposit $5,000. What you put in originally is your p-value, and then what you end with is your f value. So the fact that this said how long until there is 8,000, that's a futuristic value, okay? The rate is going to be 6%. We know that's 0.06. And then monthly tells us that n equals 12. So we're going to give ourselves the compound interest formula. You copy it from your packet or right from here. And then I'm going to put all the variables into their places. So we have 8,000 equals 5,000 times 1 plus the rate is 0.06 divided by n, which is 12. And then nt is the exponent, so n is 12, t is just t. So we're going to have 12t up there on the top. Okay, you're going to notice this problem is a little bit similar to the one we did above here. And the one that we did above, we still had the same rate, 6%. It was compounded monthly, and there you have the 12t up there as well. So from here, you're going to see some similarities and some differences between the two examples. The first similarity, the 0.06 divided by 12, that's going to turn into 0.005, and then we're going to add 1 to it to make 1.005. So on my next step of my work in my rewrite, I'm going to change that parenthesis value to 1.005. So we got to write, need another 0. 5 grand times 1.005, and that is to the 12t power. So that's our second line of work. Now, the checklist that we did here says divide by p and clean up. So we clean this up. Now we got to divide by p. And that is $5,000, $5,000. And in my calculator, I will simplify that to be 8,000 over 5,000, and we get 1.6. So 1.6 is going to be over there left on the left. And the 5,000s just got canceled out because we divided what was being multiplied. and we're left with 1.005 raised to the 12t power. Okay, now this is the time when we're going to change from an exponent or an exponential equation to a logarithmic equation. This is going to be two different rewrites now, okay? So we're going to go back to our definition here, and it says that we're going to change this to a log with a base. So we're going to write log, and the base is 1.005. So the base is there, then comes the answer. The answer is the 1.6. And then this is all equal to the exponent, and in that case, it's 12t. So that is how to change from an exponential equation to a logarithmic equation. And if you need to see that again, also you can look up here. Make sure you got that in your notes, okay? So there's many ways to go figure that part out again. You can also look back in Desmos from day 4. We have some good examples of how to do that. Okay, so this is the part where we got a little stuck in class today because we don't all have the same calculator. So on this slide in Desmos, there's a link to a logarithm calculator. Now I happen to have that up right here, so I'm going to pull that over, and this is where you're going to put your base, and that's where you're going to put your answer. So over here we see 1.6 and 1.005. The base was 1.005, and then 1.6 right there. So we're recreating this logarithm, 1.6, and we're going to say calculate. So from that, we know to replace the logarithm with 94.2355323317, the whole 9 yards. Okay, so I'm going to write that down in where the logarithm was on the left-hand side, and I'll show you in a second. I'm just copying down the log here, and that's all equal to 12t. So let me zoom in on that so you can see. All right, so you see I replaced the logarithm with the 94. So that's if we did not multiply by 12, but you see how that's divided by, it's multiplied by 12. So to find the true answer, we have to divide and get t all by itself. And we can plug that into our calculator, or you could have gotten the log from your calculator originally, but we have 94.23553 divided by 12, and we get 7 and some change. So 7.8529608333, and that was equal to t. We like to go with 3 decimal places whenever possible, so we're just going to round it right there. So we have 7.853 years. Okay, so that is problem number 11 on page 5. I'm going to record the next example, and you should move to the next slide.